This is Synchro Systems. What is it? Synchro Systems is basically consisting out of a transmitter, receiver, construction. If you look at it closely, it resembles small AC motors. Also consists out of a rotor and a stator, and then stator windings are 120 degrees apart, similar to AC motor. And then what does it do basically? So you sit on the one side, there's the schematics. So you sit on one side, you sit with a transmitter, other side you sit with a receiver. And then this one will, if you want this one to move to 180 degrees phase shift, just move to 180 degree. The other one will also align itself with that one to 180 degrees. If you want this one to turn to 240 degrees, then this one, the receiver, will also turn to 240 degrees. So it's rotary movement. You achieve it, the best way to achieve it, or most practices make use of these cylindrical shape that looks exactly same like AC motor structure. You have your stationary part and your rotatory part, rotor and stator. So you achieve rotary movement by making use of various connections, different coupling connections. Okay, so looks exactly like AC motors. Inside, 120 degrees out of phase, consists of a stator and a rotor. Then it works on the basis of Lenz's law, or let me rather say, it works on like a transformer, principle of electromagnetic induction. And that law you know from N1. You set up a magnetic current current flows through a conductor, flow in a conductor, change in the electrical field surrounding the conductor. Direction of the flow of current is as such to produce a magnetic field opposing the original change in the external magnetic field. That you already know how a transformer works by current and voltage. Set up a magnetic field, you then induce a voltage and then a magnetic field in the secondary side of a transformer of same frequency, opposite in magnitude, opposite in opposite cause a circulate in such produce a magnetic field opposing the original change in external magnetic field. Okay, then so that's basically the operating principle. So you're gonna have to achieve movement, because you're gonna align one. If you change there's a transmitter and a receiver, so if you change the transmitter to point at 180 degrees, the receiver must also point to 180 degrees, so there must be movement there. So if you just look closely here is the 3 windings there, 1 2 3, and then if you have to look at it closely, S1 is in parallel with S3, this one is in parallel with this one. So if you have two stator windings in parallel, same like resistors, and current flows through it, you will know that the current will be divided there, and there it will be the sum. It will be the sum of the currents. So divided there, and that will be the sum, which means if there's a magnetic field, it means the magnetic field created there would be half the size of this one. I mean that magnetic field will be half the size of that magnetic field. This one will be half of this one. This two together will be equal to that one. So if you have to put a conductor in the middle there, this conductor will experience a force, will move towards that side. That's how you create movement. That is just to know how you create movement in these synchronous motors. Then if you look at the connections, this is if it's standard coupling where it's in phase. Now here you will see there's the drawing. You must be able to know how to draw this. You just apply voltage, AC voltage, R1 and R2, that is referring to your rotor, and the stator windings 1, 2 and 3, That's your transmitter on the one side. This connect via signal frequency, because this will be far over long distance. This will be your receiver, and that's also a router, stator 2, 1 and 3. So if you look at the connections, you will find that stator 2 is connected to stator 2. Stator winding 1 is connected to stator winding 1, and stator winding 3 is connected to stator winding 3. R1 is connected to R1, and R2 is connected to R2. So all the points are exactly connected to each other, same points. And there you also have a table, TX, RX. TX stands for transmitter, and that's receiver. And there it also shows R1, R1, R2. R2 is S1 connected to S1, and S2, S2, S3, and S3. How does it work? So current flows through here, connected to your supply. Set up, create a voltage here. Current flows here, and then it induce. That's what it does. Induce voltage in the stator coils. So it induces a voltage in the stator coils. We then set up a magnetic field. The same thing happened on the side. Current flows through there, induce a voltage in the stator windings, in each of these stator windings. Important in this condition, the induced voltages in the stator coils of both the transmitter and receiver are equal and opposite. Remitter and receiver, the stator coils, they equal and opposite, and as a result causes the voltages to cancel and reduces the current to zero. And with zero current through the coils, the system remains in balance. So the voltages are equal and opposite. They're equal. So the coils are equal and they're opposite. So they cancel out. Zero current, so they will align, no movement, so they will align exactly, no phase shift, no movement will take place. So this will be for standard coupling. Then next one will be, if you look at 180 degrees phase shift, again transmitter receiver. And this is how you connect it. Here you will see the router is swapped around R1, R2, R2, R1. In this case, because it's swapped around, you will find that the direction of the current that flows through the transmitter router is opposite to that of the receiver router, because you swapped it now around. So you swap it around, current that flows through the transmitter router is opposite to current flow through the receiver router. That will have a resultant effect that, well, receiver, it will have a resultant that your whole direction will now shift to 180 degrees out of phase because of this swap that you made here. The router is swapped around, that one is swapped to that one, that one is swapped to that one. Obviously the current will be opposite in the router. Transmitter and the router current will be now opposite. So therefore the two routers would be aligned in opposite direction or 180 degrees out of phase. So because you swapped it around, current will be now opposite in this one compared to this one, because you swapped it around. That's why they will align, the routers will align 180 degrees out of phase. Then for 240 degrees phase shift, to achieve that, there's your table. That's how you connect it. Same, swap, they swap around. Then as a result, connecting the leads like that, the effect, you know the drawing, will have that this transmitter and receiver will be 240 degrees phase shift between them. If you want to achieve an opposite direction rotation, there's a drawing, and that is how you connect it. R1, R1, R2, R2, S1, S3, and S2, S2, S3, S1. That's how you achieve that. You need to know these drawings, how to connect it with the tables. And then you need to know, obviously you need to know Lenz's law, and you need to have an explanation of how it works. But if you know this, if you can already explain Lenz's law or the principle of electromagnetic induction, you would be able to explain how it works. You must know synchro systems consist of a transmitter and a receiver. One on the one side, one on the other side. They connect via a signal at a certain frequency. That's how they line up. It's like almost like a radio controlled car, toy car. If you turn right, it must turn right. Turn left, it must turn left. So we are looking at angular displacement. Of course, it's rotating, and the rotating, that's why best suited for this would be if you take a AC motor, because it's rotating, so you can turn it to whatever angle you want to achieve. You also need to know the advantages of synchronous and where it's been used. There is examples, and then also I gave some questions and possible questions that you normally ask out of question papers. And that's it for synchronous.